Good morning, students. Let us continue from where we have stopped the previous video. So the 14th question is integral cos x into cos 3x dx on R. So as we have seen before, integral cos x into cos 3x dx. So all that we need to do is just to multiply and divide with the 2. So this is 2 cos x into cos 3x dx. So this is equals to 1 by 2. We have the formula for this in transformations that we have studied in the first year intermediate in trigonometry. So 2 cos a cos b is cos a plus b plus cos a minus b. So this is cos a plus b x plus 3x plus cos x minus 3x whole dx. So 2 cos a cos b is cos a plus b plus cos a minus b. So 1 by 2 into cos x plus 3x is 4x plus cos x minus 3x is cos minus 2x. Cos minus 2x is plus cos 2x because cos is the even function. So this is cos 2x dx. So this is equals to 1 by 2 integral cos 4x dx plus integral cos 2x dx. So this integral dx is distributed for these two integrands. So this is 1 by 2 into integral cos 4x. Let us treat it as x. Integral cos x dx is sin x. So sin in here x is 4x by d by dx of 4x. Whichever that we have taken it to be x, by d by dx of that we have to do. D by dx of 4x is 4. In derivative into d by dx of 4x. So into and divided are the opposite processes. Therefore differentiation and integration is also opposite processes. Instead of into d by dx of 4x, by d by dx of 4x, that is 4 we have to do here, plus this is sin 2x by 2 plus constant of integration c. So the next question is integral cos power 4x dx on R. So this cos 4x can be written as cos square x whole square dx, or you may even write it as cos cube x into cos x. So cos cube x can be derived from cos 3x, 4 cos cube x minus 3x. From that cos cube x we can derive into cos x, and we can proceed from there onwards. Otherwise cos power 4x can be written as cos square x whole square dx. So this is equals to cos square x can be written as 1 plus cos 2x by 2 whole square dx, which we have discussed in the last year. Cos square x is 1 plus cos 2x by 2. Sin square x is 1 minus cos 2x by 2. So this is equals to 1 by 2 whole square is 1 by 4 integral. This is 1 plus cos 2x whole square dx. This I have written here. So 1 by 4. This is a plus b whole square. A square plus b square plus 2ab. 1 square is 1 plus cos square 2x plus 2 into 1 into cos 2x. So 2 cos 2x whole dx. So this is equals to 1 by 4. So this is here 1 plus cos square x is 1 plus cos 2x by 2, while cos square 2x is 1 plus cos 4x by 2, because that's what we have discussed in the last year, multiple and submultiple angles. Cos square x, so 1 plus cos 2 into this x. Cos square 2x is 1 plus cos 2 into 2x. 2 into 2x is 4x. So cos square 2x can be written as 1 plus cos 4x by 2 plus 2 cos 2x whole dx. So this is 1 by 4. So LCM, if you take 2 as an LCM, 2 into 1, 2 plus 1 plus cos 4x plus 2 into 2, 4 cos 2x whole dx. So 1 by 4, 2 plus 1, 3 plus cos 4x plus 4 cos 2x whole dx. So 1 by 4 integral. So here integral dx is distributed to 3 integrands. So integral 3 dx plus integral cos 4x dx plus integral 4, I'm separating from the process of integration, integral cos 2x dx. So 1 by 4 integral 3, this integral 3 dx is 3 into integral 1 dx. Integral 1 dx is x. So 3 into x, 3x plus cos 4x is sine 4x by 4. That's what we have seen it before. Integral cos 4x is sine 4x by 4 plus 4 into integral cos 2x is sine 2x by 2. So 2 times it is cancelled plus constant of integration c. So take 4 as an LCM. So take 4 as an LCM. 4 into 4. So 16 into. So this is 4 3s are 12x plus this is sine 4x plus this is 4 2s are 8 sine 2x plus constant of integration c. A small mistake we have committed here. 2 we have taken LCM. 2 1s are 2 plus 1 plus cos 4x. 2 2s are 4 cos 2x. This 2 is the LCM. 2 4s are, it will become 8 here. So similarly this is 8. This is also 8. So now this is also 8. So 3x plus sine 4x by 4, everything same. So here LCM is 4. LCM is 4. So 4 3s are 12x sine 4x. 4 2s are 8 sine 2x. By 4 LCM, 4 8s are, this is 32. Now this is the final answer. Integral x into root of 4x plus 3 dx on minus 3 by 4 to infinity. So as we have discussed before, whichever that is in root is to be treated as t square instead of t, so that the square and root will be eliminated. Let 4x plus 3 is equals to t square. Now differentiate 4 dx is equals to t square derivative is 2t dt. So 2 times, therefore dx is equals to t by 2. On transposing, this 2 will be divided dt. So from this 4x is equals to t square minus 3. 4x is equals to t square. This plus 3, if you transpose onto another side, minus 3. So further from this, x is equals to t square minus 3 by 4. This 4 is multiplying. If you take to that side, it will be dividing. Now, this is equals to, here this x is equals to t square minus 3 by 4. This x is equals to t square minus 3 by 4 into root 4x plus 3. 4x plus 3 is t square, while root 4x plus 3 is root t square, which is t, into dx is equals to t by 2 dt. this x is equals to t square minus 3 by 4 that we have written here. Root 4x plus 3 is root t square, which is t. So this and this we have settled. And dx is equals to t by 2 dt. So this is equals to 4 2s are 8. So 1 by 8 into. So t square minus 3 into t into t is t square dt. So this is equals to 1 by 8. T square into t square is t power 4 minus 3 into t square is 3t square dt. So this is 1 by 8 into integral t power 4 dt minus 3 into integral t square dt. So this is 1 by 8 into integral t power 4 dt is integral x power n dx is x power n plus 1 by n plus 1. So this is t power 4 plus 1 by 4 plus 1, t power 5 by 5 minus this is 3 into t power 3 by 3 plus constant of integration c. So this is equals to 1 by 8 into, so 4x plus 3 is t square. From this 4x plus 3 is t square. From this t is equals to root of 4x plus 3. So therefore t is equals to 4x plus 3 whole power 1 by 2. So this t is equals to how much now? 4x plus 3 whole power 1 by 2 whole power 5. A power m whole power n, a power mn. So whole power 5 whole power 1 by 2. So 5 by 2 minus this is 3 into this 3 gets cancelled here. Now t is equals to how much? 4x plus 3 whole power 1 by 2 whole power 3. So this is 4x plus 3 whole power 1 by 2 whole cube. So 3 by 2 plus constant of integration c. So this is the final answer. So this is by 5. So 8 5s are 40. So 1 by 40 into 4x plus 3 whole power 5 by 2 minus 1 by 8 into this. So 1 by 8 into 4x plus 3 whole power 3 by 2 plus constant of integration c. Integral dx by square root of a square plus b plus cx whole square. So here b plus cx, let b plus cx is equal to t will take. Now differentiate d by dx of b, constant derivative 0. So c is the constant, separate it from the process of integration. Dx is equals to dt. Therefore dx is equals to dt by c. So this is equals to dx is dt by c. So 1 by c I am writing outside since this is a constant into dt by square root of a square minus of this b plus dx is t, its square. So t square. So this is of the form dt now. So 1 dt we can write. So we have the formula integral 1 by square root of a square minus x square dx. Integral 1 by square root of a square minus x square dx is sine inverse x by a. So 1 by c into sine inverse x by a. So here x is the variable t. So t by a plus constant of integration c. So this is 1 by c into sine inverse t is to be replaced as b plus cx. So b plus cx by a plus constant of integration c dash, because here this is c and this is c. So to show the difference, I have written c dash instead of c. So the next one is 18th. Integral dx by square root of a not square root of a square plus b plus cx whole square. So here the everything process is same. So this b plus cx is to be taken as t, c dx equals to dt, dx equals to dt by c. So this is equals to dx is dt by c. So 1 by c into dt by a square plus this b plus cx is t square. So now it has become integral. This is 1 by c into 1 by a square plus t square dt. So what is integral 1 by a square plus x square dx? 1 by a tan inverse x by a. So this is equals to 1 by c is same. The formula for this is 1 by a tan inverse x by a. X is here t by a plus constant of integration c. So already c is existed here. So to show the difference, c dash will write. So this is 1 by ac tan inverse. This t is to be replaced as what we have taken it before. This t is b plus cx. So this is b plus cx by a plus c dash, which is the constant of integration. Integral dx by 1 plus e power x, where x belongs to r. So this is equals to integral dx by, so 1 plus e power x. Let us take e power x as common. So then 1 plus 1 by e power x. So e power x into 1 is e power x. E power x into 1 by e power x. E power x gets cancelled. We are left with 1. This is equals to dx by, this is 1 by e, this is 1 by e power x is, this is 1 by e power x is e power minus x dx. 1 plus 1 by e power x is e power minus x. We know that e power minus x derivative is minus e power minus x. So here we don't have minus here. So without loss of generality, we will write it as minus of minus e power minus x dx by 1 plus e power minus x. So let 1 plus e power minus x is equals to t we will take. Then minus e power minus x dx is equals to dt. So this is equals to, minus is same. So here minus e power minus x dx is dt. So integral dt by 1 plus e power minus x is t. So this is minus 1 by t dt. dt by t is minus integral 1 by t dt. So this is equals to minus integral 1 by x dx is log mod x. Integral 1 by t dt is log mod t. So log modulus of t plus constant of integration c. So this is minus log t is log t power minus 1, according to the property that m log a is log a to the power of m plus c. So this is log, the value of t is 1 plus e power minus x. So t is to be replaced as 1 plus e power minus x inverse plus c. So this is log. So let us suppose this to be a power minus 1. A power minus 1 is 1 by a. So this is 1 by 1 plus e power minus x plus c. So this is log 1 by 1 plus e power minus x is 1 by e power x plus c. So this is log 1 by, so LCM is e power x plus 1 by e power x plus c. So this is 1 by a by b is b by a. So this is log e power x by e power x plus 1 plus c. Now we know log a by b is log a minus log b. So this is log e power x minus log e power x plus 1 plus constant of integration c. So log e power x, so this is to the base e. So this is equals to x because we have the property log n log a power n to the base a is this n. Log a power n to the base a is n. So this is log. So in the place of n, x is there. So x minus log e power x plus 1 plus constant of integration c is the final answer for this integrand. Integral of x square by a plus bx whole square dx. So let us suppose a plus bx to be t. Then b dx is equals to dt. Therefore, dx is equals to dt by b. This is equals to, from this, dx is equals to t minus a. Dx equals to t minus a. From this, x is equals to t minus a by b. X is equals to t minus a by b. So now let us substitute everything in this. The value of x is what we have derived, just derived, t minus a by b square by this a plus bx is t, its square, t square into dx is equals to dt by b. So this is equals to integral. This 1 by b I am separating from the process of integration. So this is t minus a whole square. Already 1 by b is there into 1 by b square. So this is totally 1 by b cube by 1 into this is 1 by b square dt. So this is equals to 1 by b cube integral. So expand this. A minus b whole square. So t square plus a square minus 2at by t square whole dt. So 1 by b cube. This is t square by t square is 1 dt plus a square into a square by t square. A square if you separate from the process of integration, this is integral 1 by t square dt minus 2a separated from the process of integration. T by t square is 1 by t. So this is integral 1 by t dt. So this is equal to 1 by b cube into integral 1 dt is integral 1 dx is x. So integral 1 dt is t plus a square. Integral 1 by x square is minus 1 by x. Integral 1 by t square dt is minus 1 by t. So this is minus 1 by t minus 2a. Integral 1 by x dx is log mod x. This is log modulus of t. So plus constant of integration c. So this is equals to 1 by b cube into the value of t is a plus bx. So let us replace with a plus bx in the place of t. This is minus a square by t value is a plus bx minus 2a log t value is a plus bx plus constant of integration c. Integral of x square by root of 1 minus x dx. As usual, whatever that is under root is to be treated as t square. So let 1 minus x is equals to t square. So now differentiate minus dx is equals to 2t dt. So therefore, if you multiply with minus on both the sides, then we'll get dx is equals to minus 2t dt. So from this, 1 minus t square is equals to x. 1, this plus t square if you transpose onto this side, minus t square, this minus x if you transpose onto this side, plus x. So this is equals to x square is, x is 1 minus t square, x square is 1 minus t square whole square by 1 minus x is t square, while root 1 minus x is root t square, which is t here, into dx value is minus 2t dt. Minus 2t dt. So t gets cancelled. So this is minus of this 2. I'll write outside the integration since it's a constant. So this minus 2 is this. So this is 1 minus t square whole square dt. So this is minus 2 a minus b whole square, 1 square, t square whole square, t power 4 minus 2ab, 2 into 1 into t square. This is 2t square dt. So this is minus 2. So this is integral 1 dt plus this is integral t power 4 dt minus 2 into this is integral t square dt. So this is minus 2 into integral 1 dt is t plus integral t power 4 dt is t power 5 by 5 minus 2 integral t square dt is t cube by 3 plus constant of integration c. So this is equals to minus 2 1 minus x is t square while t is equals to root of 1 minus x or 1 minus x whole power 1 by 2. So the value of t is 1 minus x whole power 1 by 2. So t value here is 1 minus x whole power 1 by 2 plus 1 by 5 into the value of t is 1 minus x whole power 1 by 2 whole power 5 by 2. So this is 1 minus x whole power 5 by 2 minus 2 by 3, t value is 1 minus x whole power 1 by 2, 1 minus x whole power 1 by 2 whole cube, 1 minus x whole power 3 by 2 plus constant of integration c. So this is equals to minus into minus plus 2 to the 4 by 3, 1 minus x whole power 3 by 2. So this is minus 2 into 1 by 5 is minus 2 by 5 into 1 minus x whole power 3 by 2 minus 2, 1 minus x whole power 1 by 2 is root of 1 minus x plus constant of integration c. So far we have discussed mainly the integration of algebraic and trigonometric functions. So in this module we will be continuing them algebraic and trigonometric functions, along with that inverse trigonometric functions, logarithmic and exponential functions as well. So sometimes might not be possible to directly evaluate the product of two functions using the standard formulae. So their integration by parts is useful. So let us see how it works. So if u and v are two differentiable functions, then we have d by dx of uv is equals to u into d by dx of v, u into dv by dx plus v into du by dx. U first function into d by dx of second function plus second function into d by dx of first function. So this is equals to u into dv by dx is equals to d by dx of uv minus v into du by dx. v into du by dx. Now integrating on both sides. Integrating on both sides. Integral u dv by dx into dx. Whenever we are applying integrating on both sides, integral dx, integral is associated with the differential operator dx. So this is equals to integral of, for this also, d by dx of uv minus v into du by dx, du by dx whole dx. Now this is equals to integral u into dv by dx is equals to, here let u is equals to f of x and dv by dx is equals to g of x we will take. Now let us apply integrating on both sides, then we will get dv by dx into dx is equals to integral of g of x dx. So this is equals to integral dv by dx into dx is nothing but, so integral dv is equals to integral g of x dx. Integral 1 dv is v. So therefore v is equals to integral g of x dx. So let us continue from here. Integral, the value of u is f of x into dv by dx is g of x into dx is equals to, so this is equals to integral d by dx of uv into dx minus integral v du by dx into dx. So this is equals to, this is d by dx of uv dx. LHS is integral f of x into g of x dx is equals to, so here integral d by dx of uv dx, so this will be uv, so d by dx of dx gets cancelled. Integral duv is uv, so u is equals to f of x, v is equals to integral g of x dx. So this is integral g of x dx minus integral of, so here du by this is d by dx of, this is d by dx of, this u is equals to f of x. D by dx of u is f of x, v is integral g of x dx, integral g of x dx, and this dx is whole dx. Again, integral f of x into g of x dx is equals to integral d by dx of u v dx is integral and derivative are reversal processes. Therefore, this is uv we are left with, and u here is f of x, v here is integral g of x dx. So f of x into integral of g of x dx is this totally minus integral of, so here du by dx is d by dx of u. So d by dx of u value is f of x. So d by dx of f of x. Du by dx we have seen here. Next, v value is integral g of x dx. Integral g of x dx. This dx is this here we have written. Therefore, integral f of x into g of x dx is equals to f of x into integral of g of x dx minus of integral of d by dx of f of x into integral g of x dx whole dx. So, if you are to evaluate the product of two functions, then product of two functions, integral of product of two functions is equals to first function into integral of second function dx minus integral of differential quotient of the first function or derivative of first function into integral of second function dx whole dx. So this is particularly useful when you are required to evaluate the integral of product of two functions. So especially when you are to evaluate some special functions like integral root of a square minus x square dx or integral root of a square plus x square dx or integral root of x square minus a square dx or integral log x dx, logarithmic functions, because d by dx of log x we know 1 by x. So d by dx of log x is 1 by x. Integral 1 by x is log x plus c. But actually integral log x dx or log of 1 plus x or log x square dx etc. that we don't know how to evaluate. Or if we are to evaluate integral sine inverse x dx or integral secant inverse x, tan inverse x, okay, etc. So, for example, tan inverse x dx. So, we don't know how to evaluate. But here, in these situations, so integration by parts method is useful. Not only here, if you are asked to evaluate the integral of x sine inverse x dx. So x sine inverse x dx, this is of the form f of x into g of x dx. But a natural question generally arises as to which function we have to take it as f of x. So f of x is the first function. So x is to be treated as f of x or sine inverse x is to be treated as f of x. So that can be based on the phrase I laid. So whenever you are asked to evaluate the integral of two functions, the product of two functions, for example, you are asked to find out integral x sine inverse x dx. Here, this is clearly the product of two functions f of x and g of x dx. But we don't know which function is to be taken as the first function. That is depending on the phrase that I laid. Here, I stands for inverse trigonometric functions. Inverse trigonometric functions. That is, example, sine inverse x, secant h inverse x, etc. L stands for logarithmic functions. Logarithmic functions. Example, log x log 1 plus x square, etc. A stands for algebraic functions. Algebraic functions. 1, because 1 is equals to x power 0, x power minus 1, x square, etc. So we can understand as x power something. Those are all treated to be algebraic functions. T stands for trigonometric functions. So trigonometric functions, we know sin x, secant square x, tan x, etc. And E stands for exponential functions. Exponential functions, example, e power x, a power x, etc. So the main difference between algebraic function and exponential function is algebraic function x power something, while exponential function is something to the power of x. For example, integrals x sin inverse x dx. Here x is algebraic function because this is x power 1. X power something. Algebraic sin inverse is inverse trigonometric function. Now in IIT, I comes first. Therefore this is f of x and this is g of x. So this method of by parts is particularly useful when the integral contains the product of two functions. So sometimes it may be useful when the integrand contains integral log x, integral root of a square minus x square dx, integral sin inverse x dx, integral e power x dx, etc. So logarithmic functions, inverse trigonometric functions, some special functions like root of a square minus x square, root of a square plus x square dx, and the exponential functions. Okay, likewise. So here the second function is to be treated as 1. So log x is log x into 1 dx. Here integrand a square minus x square into 1. So f of x is root of a square minus x square. 1 is g of x. 1 is basically g of x only, the second function. Let us discuss some examples based on this concept. So for example, integral root of a square minus x square dx. So this kind of function we have seen before. So integral root of a square minus x square dx is equals to x by 2 root of a square minus x square plus a square by 2 sin inverse x by a plus c. So let us do how. So there x is equals to a sin theta we have taken and proceeded. So here integral root of a square minus x square into second function is to be treated as 1. So this is f of x and 1 is to be treated as g of x. So according to by parts, first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So first and foremost, let us take this to be I, because this function it is going to be repeated. So this is root of a square minus x square, integral 1 dx is x minus integral of, let us suppose this to be x because we know d by dx of root x, 1 by 2 root x. So this is 1 by 2 root of a square minus x square into whichever that we have treated it to be x, we need to differentiate it later. So into dy by dx of a square minus x square. A square derivative is 0 minus x square derivative is 2x. Integral 1 dx is x whole dx. So 2 gets cancelled. So this is equals to x root of a square minus x square minus integral of x into x square. This is minus x square by square root of a square minus x square dx minus x into x minus x square by root of a square minus x square. So here let us add and subtract with a square without loss of generality. So this is equals to x root of a square minus x square minus, so this is a minus b by c, a by c minus b by c. So this is a square minus x square by root of a square minus x square is root of a square minus x square. So integral dx minus into minus plus. So a square being constant, separate it from the process of integration. So this is 1 by root of a square minus x square dx. So this is equals to x root of a square minus x square minus this, we have treated it to be I. So this is I and this is all I is equals to plus a square. We know integral 1 by root of a square minus x square is sine inverse x by a. So this is minus I, if you take to this side, 2i is equals to x root of a square minus x square plus a square sine inverse x by a. So this 2, if you transpose onto another side, it will be dividing with both of them. So therefore, I is equals to x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus constant of integration c. Now let us see another example of integral log x dx. So integral log x dx, we don't know how to do this, but this is log x into 1 we can take. So the second function is treated as unity. So this is f of x and g of x. So we know that integral f of x into g of x dx is equals to f of x into integral g of x dx minus integral of d by dx of f of x into integral g of x dx whole dx. So this is equals to f of x is log x into integral 1 dx minus integral of d by dx of f of x is log x into integral 1 dx whole dx. So this is equals to log x integral 1 dx is x minus d by dx of log x is 1 by x. Integral 1 dx is x whole dx. So x gets cancelled. So this is x log x minus integral 1 dx is x plus constant of integration c. Therefore this is integral log x dx is equals to. And what if you are asked to find out integral sine inverse x dx? So here also the second function is sine inverse x into 1 dx. So first function sine inverse x into integral second function dx minus integral of d by dx of f of x sine inverse x into integral 1 dx whole dx. So this is equals to sine inverse x integral 1 dx is x minus d by dx of sine inverse x is 1 by root of 1 minus x square. Integral 1 dx is x whole dx. So this is x sine inverse x minus here 1 minus x square derivative is 2x, but here x we have. So therefore 1 by 2 into this is 2x by root of 1 minus x square dx. So this minus we will write it as plus of minus 2x. So this is equals to x sine inverse x plus 1 by 2. 1 minus x square derivative is minus 2x. So this is f dash x by root f of x. 2 root f of x. 2 root of 1 minus x square. So 2 gets cancelled plus constant of integration c. Therefore, integral sin inverse x dx is equals to x sin inverse x plus root 1 minus x square plus c. So the more problems based on the method of by parts will be discussed in the next video. Thank you.